Hi friends, today we are going to see about GEO stationary Earth orbit satellites. The GEO satellites are originally proposed by Arthur C. Clarke. The geostationary satellites circular orbits about the equator. The orbit of the geostationary Earth or satellites are in circular and it locates above the equator. The angular separation between the satellites is about 2 degree and allows 180 satellites placed above the Earth. The orbital height above the Earth is 23,000 miles or 35,000 kilometers. The round trip time to satellite to complete the Earth is about 0.24 seconds. The GEO satellites require more power for communications. The signal to noise ratio for GEO is worse because of distance involved. A few GEOs can cover most of the surface of the Earth. The polar regions cannot be seen by GEOs. Since they appear stationary, GEOs do not require tracking. Geostationary Earth orbit satellites are good for broadcasting to wide areas. Some of the early experiments are done by many countries, among that Echo 1, Echo 2 and Telstar Syncom 2 are some of the examples. The major problem for satellites is as follows: positioning in orbit, stability of the satellite, power, communications, harsh environment are some of the major problems for satellites. The positioning, this can be achieved by several methods. One method is used to small rocket motors to position in the correct orbit. The use of fuel. Over half of the weight of most satellites is made up of fuel. Often it is the fuel availability which determines the lifetime of a satellite. Commercial life of a satellite typically 10 to 15 years. Next problem is stability. It is the vital that satellites are stabilized to ensure that solar panels are aligned properly and to ensure that communication antenna are aligned properly. Early satellites used spin stabilization. Either this required an inefficient omnidirectional aerial or antenna were precisely counter-rotated in order to provide stable communications. Modern satellites use a reaction wheel stabilization, a form of gyroscopic stabilization. Other methods of stabilization are also possible, including eddy current stabilization. Reaction wheel stabilization. In this, heavy wheels which rotate at high speed, often in groups of 4. 3 are orthogonal and the fourth is a backup at an angle to the other. It was driven by electric motors. As they speed up or slow down, the satellite rotates. If the speed of the wheel is inappropriate, rocket motors must be used to stabilize the satellite, which uses fuel. Modern satellites use a variety of power. Solar panels are now quite efficient, so solar power is used to generate electricity. Batteries are needed as sometimes the satellites are behind the Earth. This happens about half the time for a LEO satellite because the sunlight doesn't fall on the solar panel. Earth shadows only focused by the solar panels. Nuclear power has been used but not recommended. In harsh environment, satellite components need to be specially hardened. Circuits which work on the ground will fail very rapidly in space. Temperature is also a problem. So satellites use electric heaters to keep circuits and other vital parts warmed up. They also need to control the temperature carefully. Alignment is one of the major problems. There are a number of components which need alignment. For example, solar panels, antenna. These have to point at different parts of the sky at different times. So the problem is not trivial. Antenna alignment. A parabolic dish can be used which is pointing in the current general direction. Different feeder horns can be used to direct out beam more precisely. Similarly for incoming beams. A modern satellite should be capable of at least 50 different direct beams. Up to this we see about the geostationary Earth orbit and the major problems in positioning a satellite in orbit. Next, we are going to see about satellite to satellite communication in the next session. Thank you.